Lesson 10.7 is about trigonometric functions. Now, these are our sine, cosine, and tangent functions. So a big part of what we're going to go over today is this phrase, so, ka, and toa. Always try to remember so, ka, toa. Whenever you think of trigonometric functions or trigonometry, so, ka, toa. Sine, cosine, and tangent. We'll go over what these O's, A's, and H's mean as well. So some key terms to go over first. Trigonometry is the study of relationships among the angles and sides of triangles. Now, normally we're going to look at all right triangles, but trigonometry also works for every single triangle there is. They don't all have to be right triangles. A trigonometric ratio is a ratio that compares the side lengths of two sides of a right triangle. So again, this refers specifically to right triangles, but we can do this with other triangles as well. Now the sine is one of our trigonometric ratios. The sine is the ratio of the opposite side over the hypotenuse. S-O-H. S-O-H. So. Cosine is the ratio of the adjacent over the hypotenuse. C-A-H. C-A-H. So, ka. And then our last one, tangent, is the ratio of the opposite over the adjacent. T-O-A. Tangent, opposite, and adjacent. Okay, so these three are our three main trigonometric ratios. Now this is kind of what it looks like in other terms here. So our key concept is the trigonometric ratios. So in words, we would say that the sine of angle A, so all the time we're going to be looking at this angle right here, given this triangle. This is a regular right triangle. We have angle C right here is a right angle. So little c over here is the side. Remember, we would call this the hypotenuse, call it H. Going from A, the opposite side over here is A, call that O for opposite. And again, going from A, its adjacent side, that's the side right next to it. So from any angle, the side across from it is opposite, the side next to it is adjacent, and the side that is across from the right angle is always your hypotenuse. So there's an O, an A, and an H. Now the sine, S-O-H, is the leg that's opposite of it. O, our opposite, over the hypotenuse. So sine, it's opposite over hypotenuse. In this case, the sine of A is going to be A over C, opposite over hypotenuse. The cosine of A is adjacent over hypotenuse. So this side B over C, or adjacent over hypotenuse. And the tangent of A is opposite over adjacent. So O over A, or we call it side A over side B. Okay. Now, all of these are technically arbitrary. What I mean by that is they're relative to what you're looking at. If these are the sines, cosines, and tangents of A, well, if we were to get rid of this and say now all of a sudden we're looking at angle B. Well, what side is opposite from B? It's no longer this one here. Our opposite would be over here. Our adjacent would be over here. So if we're looking from angle A, this is opposite, this is adjacent. If we're looking from angle B, this is opposite, this is adjacent. So it all depends on what you're looking for. But this is how we would find those ratios. We would just use one side over another. So let's try this out. A couple examples here. Remember, so, ka, toa. The sine is the opposite over hypotenuse, the cosine is the adjacent over hypotenuse, and the tangent is opposite over adjacent. If you can remember so, ka, toa, this will help you remember which one is which. So our first example says we need to find the sine of angle C. Angle C is right here. So the first thing we want to do is label all of our pieces. Okay, hypotenuse is always across from the right angle, so our H is going to be right here. If this is C right here, the one we're looking for, then we go opposite right across from it. Here is our opposite side, and then here's the adjacent side, the one that's right next to it. Okay, so we have hypotenuse, opposite leg, adjacent leg. If we are looking for the sine of C, sine right here is opposite over hypotenuse. Our opposite was 24, our hypotenuse was 40, so we would say the sine of c is 24 over 40. That can be reduced, though, down to 3/5. So we would say the sine of c is 3/5, and that would be our final answer. Always reduce if you can. All right, now we're looking at the cosine of z. Here is angle z, so the first thing we want to do is recognize which piece is which. Here's our right angle, so this is the hypotenuse. Looking at z, going across from it would be our opposite, so that's 18. And the other leg here, a, or 24, would be a, the adjacent side. Now we want cosine of z. So cosine is adjacent over hypotenuse. So we'd be using 24 over 30, adjacent over hypotenuse. Now again, 24 out of 30 can be reduced down to 4/5. Divide both of those by 6, we get 4/5, and that would be our final answer. We would say cosine of z equals 4/5. Do one more example. We want the tangent of c. Well, here is angle c. 9 is opposite. 41 is the hypotenuse. And 40 is the adjacent. Tangent is opposite over adjacent. So it's 9, the opposite, over 40, the adjacent. That one won't actually reduce. So we would just say simply tangent of c is 9/40. Now these examples say find the following values to the nearest 10,000th using your calculator. Now these ones, you're literally just plugging in the tangent of 85 degrees into your calculator. There should be a button that says tangent, T-A-N, and then you just type in 75 degrees. Now make sure that your calculator is set up to do degrees. Okay, so normally there's either a menu or a setup button, and you change your angles. You don't want them to be in radians or gradients. You want them in degrees. So there should be an option for D, E, G, so that you're looking at your angles in degrees. So it's tangent of 85 degrees. When you type that into your calculator, you'll get about 11.4301. Remember, it said round to the nearest 10,000th, so we go out to 4 decimal places. Now, why does this say tangent of 85 degrees? Well, again, these ones are saying tangent of an angle. So what they're saying is, what if we knew that this right here was an 85-degree angle? This piece right here. If we knew it was 85, then we would know that the ratio, this over this, 9 divided by 40, would come out to this piece here, 11.4301. So although we might not know our numerator and denominator, we know that when you actually divide them out, you'd get 11.4301. That would be the tangent or the trig ratio. Same thing for cosine of 21. You're just plugging that in. There should be a cosine button, C-O-S, and then 21. Again, make sure it's in degrees. When you type that into your calculator, you should get about 0.9336. This is your cosine of 21 degrees. Using your trigonometric ratios, you can find the missing side in a right triangle. If you're trying to find the missing side in a right triangle, when given another side and an angle, you use the given angle and think about what sides, so again, the opposite, the hypotenuse, the adjacent, of the right triangle that you are dealing with, given that angle. Then you'll use SOHCAHTOA to tell you which trig function to use, and just plug it all in and solve it like an equation. So let's see what that looks like. Again, never forget SOHCAHTOA. This is going to be the most important piece you deal with in right triangle trigonometry. Now our example says find the missing side in the following examples and then round to the nearest tenth. So here we have an angle that is 35 degrees. Now from this angle we are looking at two different sides. Now here is the right angle. So this side over here is our hypotenuse. If this is our angle in this corner, 35, that means this side, 8, is the opposite. So if we are looking at an angle, its opposite side and its hypotenuse, then OH, OH goes with sine. So we need to use the sine of this angle, the sine of 35. We'll set up our problem as sine of 35 equals 8 over x. Now you can set it up as a full proportion, do sine of 35 over 1 and cross multiply, but in the end it's going to be the same as just doing multiplying by x on both sides. Here's 8 divided by x, so we would just times x on both sides. Multiply by x on both sides of the equation. That would leave us with x times the sine of 35 equals 8. And if you don't believe me, again, we can set this up as a proportion and do the same thing. So I'm going to go like this. Put this sine of 35 over 1, and then we'll cross multiply. This times this, 1 times 8. 1 times 8 is 8. X times sine of 35 is x times the sine of 35. From here, if we're trying to get x alone, we would divide by the sine of 35 on both sides of the equation. When we do that, our equation now looks like this. X equals 8 divided by the sine of 35. Now, on your calculator, you might want to be extra careful and put a little set of parentheses around this so your calculator knows for sure that you're doing 8 divided by all of this together. So 8 divided by the sine of 35, when you put that into your calculator, you should find that x is approximately 13.9. And that'll be your final answer. Again, it says round to the nearest tenth, and that looks like it makes sense. If this is 35 degrees, this is 8, this should be, or could be, around 13.9. It's not super, super long. It's not less than 8. The hypotenuse should never be less than one of the sides. Should definitely be longer. So 13.9 makes a reasonable answer there. Let's look at our second example here, example 7. We've got this angle, 49. If here's the right angle, then we know that 7 is our hypotenuse. And going from our angle of 49, this x that we're looking for is the adjacent side. Okay, it's not opposite, it's over here, it's right next to it. So if we have adjacent and hypotenuse, looking at SOHCAHTOA, which one has adjacent and hypotenuse? Right here in the middle, the cosine. So we will be looking for the cosine of 49 is adjacent over hypotenuse, so it's x over 7. Again, if you want to make it a proportion and do cosine 49 over 1, and then cross multiply, you can. Either way, basically what's happening is we're just multiplying 7 on both sides, and it's going to look like this. 7 times the cosine of 49 equals x. Plugging that into your calculator. Again, just to be careful, it might be helpful to put an extra set of parentheses around this. 7 times the cosine of 49 degrees will come out to, oops, get rid of that, approximately 4.6. So x, that leg, the length over there, would be about 4.6. And again, that makes sense. If our hypotenuse here is 7, this leg should not be any longer than 7. Looks like it might be around half that, maybe a little bit bigger. So 4.9, or sorry, 4.6 is a reasonable answer. Example 8. Again, we've got an angle. Across from the angle is our side 10. Since it's across, we call it our opposite. And then we have the side right next to it, x. That would be our adjacent. So what trig function uses adjacent and opposite? That would be tangent. Well, let's get rid of this. So the tangent of 41 degrees, TOA, is opposite over adjacent, 10 over x. Okay, to get x out of the bottom here, we just multiply x on both sides. We get x times tangent of 41 equals 10. And to get x alone then, we divide both sides by the tangent of 41. Again, it might be easiest on your calculator to make sure you have an extra set of parentheses there. But to solve this, you just plug it into your calculator as 10 divided by the tangent of 41. Now what you should get in the end then is that x should be about 11.5. And again, this makes sense. If this is 41 degrees, then this would have to be 49 degrees, because all three of these have to add up to 180 degrees. A 49 degree angle should make one that's a little bit bigger than 41 degrees. and 11.5 is a little bit bigger than 10. So again, this should be a pretty reasonable answer. We're going to do our inverse trig functions on the next video.